this video, we'll be learning to balance redox reactions in acidic solutions. Now this can be done in both basic solutions and acidic solutions, but in this video we're going to be looking at acidic solutions. Now for every problem, you'll want to follow these 6 steps exactly. Don't deviate from these 6 steps at all. Balance the following reaction that takes place in acidic solution. Here we go. Let's follow the steps. Step number 1, assign oxidation numbers. Now you already know how to do this. Step number 2, identify reactant that is being oxidized and reactant that is being reduced. So these things are the reactants. Which one of them is being oxidized and which one is being reduced? Well, chlorine goes from -1 to 0. So chlorine is being oxidized. Remember, lose electrons oxidation. So if this goes from -1 to 0, its oxidation number went up. That's oxidation. Manganese is going from +7 to +2. That means its oxidation number went down. It went down because it gained electrons. So manganese is being reduced. Now let's look at step number 3. Write half reactions. And then for each half reaction, we'll have to do all of these steps here. So let's start by writing the half reactions. Here's the oxidation half reaction for chlorine. It's turning into this. And the reduction half reaction for this ion here, and it's turning into that. So once you've written your 2 half reactions, for each half reaction, you'll have to go steps A through E. So let's do the oxidation half reaction first. Let's balance elements other than oxygen and hydrogen. Okay, that would be chlorine. We have 2 chlorines on the right, so let's make 2 chlorines on the left. Step B, balance oxygen using water. Well, we don't have any oxygen, so we don't have to do step B. Step C, balance hydrogen using H+. Well, we don't have any hydrogen either, so we can skip C. Step D, if conditions are basic. Conditions are not basic, the conditions are acidic, so we can skip D as well. Step E, balance for charge by either adding electrons as a reactant or product. So let's figure out how many charges we have on each side. It looks like we have 2 negative charges on the left, and this would be 0 charges on the right. So we have to balance by adding electrons as either a reactant or product. So in this case, we should add 2 electrons as products. Now we have -2 on the left, and we have -2 on the right. Now let's complete steps A through E for the reduction half reaction. Balance elements other than oxygen and hydrogen. Okay, that would be manganese. We have 1 manganese on the right and 1 manganese on the left, so that's already balanced. Step B, balance oxygen using H2O. Alright, we have 4 oxygens on the left. That means we need to have 4 oxygens on the right. And the way that we do that is by using H2O. So now we have 4 oxygens on the left and 4 oxygens on the right. Step C, balance hydrogen using H+. So on the right, we have 8 hydrogen. So on the left, we need 8 hydrogen. So let's add 8 H+. Step D, once again, that's only if conditions are basic. So step E, balance for charge by adding electrons as either a reactant or product. So let's figure out what our charges are. We have +7 on the left. This is 8 minus 1. And on the right, we have +2. So to which side must we add electrons? That's right. We're going to be adding electrons to the left-hand side of the equation, and we'll add 5 of them. So now both sides have a charge of +2. All right, let's go on. Step number 4. Adjust coefficients to cancel electrons. So ultimately what we want to do is cancel the electrons here on the right with the electrons here on the left. So we have 2 here and 5 here. So let's look for the least common multiple between 2 and 5. And that, of course, is 10. So we're going to multiply the top reaction by 5 and the bottom reaction by 2. So multiply 5 by each coefficient, and then multiply 2 by each coefficient. What we'll create then will be 10 electrons, and of course over here 10 electrons as well. Now don't forget, you have to multiply each coefficient. So now we have 10 electrons on the right and 10 electrons on the left. Now step number 5, add half reactions and cancel like terms. So we can cancel everything that's similar. So we can cancel the 10 electrons on the right and the 10 electrons on the left. Now I don't believe there's anything else that we can cancel here. So let's go ahead and add these two reactions together. So all we've done, this is the reactant and these are the reactants. So we've combined all the reactants. And this is the product and those are the products. So we've combined all the products. And now the last step is to check and see if the reaction is balanced for mass and charge. So let's go through. We have 10 chlorines on the left and we have 10 chlorines on the right. We have 16 hydrogens on the left and 16 hydrogens on the right. We have 2 manganese on the left and 2 manganese on the right. We have 8 oxygen on the left and we have 8 oxygen on the right. So it looks like we're balanced for mass. Let's check and make sure we're balanced for charge. We have -10, we have +16, and we have -2. That sums up to +4. On the right, the only thing we have is +4. So we have +4 on the left and +4 on the right. So this reaction is balanced for both mass and charge.